go along with graphing systems of equations, we're going to take a look at graphing systems of inequalities, specifically linear inequalities. But in order to graph a system of linear inequalities, we have to remember how to graph a single linear inequality. So let's go ahead and practice that. Let's graph y is less than or equal to 4x plus 2 on the coordinate plane. So just like a regular line, we're going to get the slope and the y-intercept from the equation. The slope here is 4, and the y-intercept is 2. So let's start there. Start at the y-intercept at 2, use the slope of 4 to go up 4 over 1, or down 4, left 1. And then we're going to use a solid line because we have the equal to bar here. So remember the symbols. This is going to give us a solid line. So we're going to use a solid line here, just like this. And then we have to know where to shade our graph, and it says less than, y is less than 4x plus 2, so we will shade below the line. So all the points below the line get shaded. So this is the graph of this linear inequality. Now when we graph a system of linear inequalities, you'll see we'll graph two of these on the same coordinate plane and see where the shaded regions overlap. So here are the steps. We'll first write each equation in slope-intercept form, just like whenever you graph any line or inequality, because this is the easiest form to graph. Then you're going to graph both inequalities on the same coordinate plane, and you'll want to shade as you go, even if just a little lightly, just so you can keep track of which side of each line is being shaded. And then the solution is the set of all points in the shaded area where they overlap, where the two shaded regions overlap. And you need to shade the solution region the darkest. So let's do some examples here. Now this first one, the system is here, and they've been put in slope-intercept form for us. So the first one gets added by 2, and there's your equation there. And the second one was already in slope-intercept form. So let's go ahead and graph this one. So we start at 2. Slope is 2 over 1, so up 2 over 1, or down 2, left 1. And it's going to have a dotted line because it doesn't have that equal to bar under the symbol. So we're going to use a dotted line for this one. And it says y is less than, so that's going to shade below the line. So I'm just going to really, I guess lightly if you're using pencil, but just really short shade just so I can see which side of that line gets shaded, just for later. Now the next one, we're going to use a solid line, but we graph the intercept at 3, and the slope there is -1, so down 1, right 1. And this is why it's important to only shade lightly, because if I had really colored in this entire side, I wouldn't be able to see where I'm graphing. So it's important to mark or shade to see where the shaded region was, but just do it lightly so you can still use the graph. This one gets a solid line because of the equal to bar. And it says y is greater than or equal to, so it's going to shade above the line, so this area here. Now you want to consider your two inequalities and look at where the two inequalities were overlapping for the shaded area. And that region is where you shade the darkest. So this region right here is where my solutions are. So all the points that are shaded in are solutions. And you can erase the other shading or leave it, it's fine. But this is the solution to this system, this shaded region right here. Now in OneNote, if you're using OneNote or a similar program, you can also use highlighters. And that way you can see, if I highlight the blue line, and then I go to highlight the red line, What's nice about this program is that the highlighter will change color where they overlap. And so you can really see where the shaded region for the solution is because it's where the overlapping is. Either way, just make sure that the solution area, the solution region, is the one that is shaded the darkest. So all these points that are shaded make both of these inequalities true. Something important to note though, points on a dotted line, points on the dotted line are not in the solution. Points on the solid line are in the solution. Just like an open or closed circle for a one-dimensional inequality, these two-dimensional ones, the solid line, those points are included. The dotted line, those points are not. Let's do some more examples. So we have to graph each system and then name 3 solutions of each system. So any 3 points that are in the shaded region. All right, so y is greater than or equal to 3. That's a horizontal line here at 3. We'll use a solid line because it has the equal to bar. And it gets shaded above, greater than. The next line, y is greater than negative x plus 4. So we go up to 4. Slope is negative 1, so down 1, right 1. Up 1, left 1 as well. It gets a dotted line because it doesn't have the equal to bar. And it is also greater than, so it will also shade above. So the overlapping area here is the region that is above both lines. So right here. And that might be a little too solid just because I want to be able to see the points. So let's just shade like that. Now I have to name 3 solutions to this system. So I'm just going to pick any 3 points in this shaded area. So let's maybe 3, 5. I'll pick one on the solid line. So 8, 3 is fine. Because remember, the points on the solid line are part of it. But points out here on the blue dotted line, those would not be included. And then just for my third one, let's just say negative 2, 6. Any 3 points in the shaded region. All right, let's go on to the next one. Y is greater than negative 3x minus 5, so we're going to go down 5. Slope is negative 3, so down 3 over 1, or up 3, left 1. Like that. It gets a dotted line. And it is shaded above, so on this side. For the next one, less than or equal to negative 3x plus 2. So we'll go up 2. It also has a slope of negative 3, so this one is parallel. So when we had a system of equations, parallel meant no solution. But with inequalities, it doesn't necessarily mean that. And it gets a solid line. See if I can do better than that. Solid line there. A little better. And it gets shaded below, less than, so this side. So our overlapping area here is actually this thin strip of points between them. Because it's less than the blue line, but greater than the red line. So right between these 2 lines. And let's name some solutions here. Maybe I want to use a thinner pen. So right between. Okay, 3 solutions. So 0, 0 actually is 1. We'll use that. And then maybe negative 1, 1. And let's say 3, negative 6. So these are 3 points in that purple shaded region. All right, on part C, we have to solve for y first. So this first one, we got 2x plus y less than 4. We're going to subtract 2x. So y is less than negative 2x plus 4. Let's go ahead and graph that. Up 4, and then our slope is negative 2, so down 2 over 1. Or up 2 left 1. And it gets a dotted line because it doesn't have the equal to bar. And it is shaded below the line, so on that side. Now for the second line, we also have to solve for y, 3x minus y greater than or equal to 6. Okay, so we'll subtract 3x. Negative y is greater than or equal to negative 3x plus 6. Now here we have to divide by negative 1. And remember, whenever you divide an inequality by a negative, you have to flip the symbol. So we end up with 3x positive minus 6. So let's graph that. We're going to go down 6. Slope is 3, so up 3 over 1. And down 3, left 1. It gets a solid line because of the equal to bar that it has. Less than or equal to. And it is less than, so we're going to shade down. So you can see where the overlap is. Going to be this region right here. And now to pick 3 points. So let's say, I don't know, negative 2, negative 1. Points on the blue line in that region are fine, but not the red one because it is dotted. So how about negative 6? Nope. How about 0, negative 6? And then let's just say 4, negative 5. Those are good. Let's keep going. Example D, y is greater than negative 2. Again, we've got a horizontal line here, dotted line, and it is shaded above. We've also got y is less than 4 minus 2x. You might want to rewrite that if it helps you. Y is less than negative 2x plus 4. So we go up 4, and then down 2 over 1. Or up 2 and left 1. It gets a dotted line as well. And it's shaded below. So our overlapping area here is this region there where the two colors overlap. And let's pick 3 points. Let's say 0, 2. Now both of these are dotted, so I got to stay off the lines. A negative 3, negative 1. And let's say negative 5, 5. Okay. Next one, x plus 2y is less than or equal to 6. We'll subtract the x. So 2y is less than or equal to negative x plus 6. Divide everything by 2. And y is less than or equal to negative 1/2 x plus 3. So let's graph that. Up 3. Slope is negative 1 over 2. So down 1, right 2. Or up and left. It gets a solid line because of the equal to bar. And it is shaded below. Let's take a look at the other one. Negative x plus y is less than 0. So we'll add x to both sides. Y is less than x. And that's it. So this one starts at the origin and has a slope of 1. So up 1, right 1, or down 1, left 1. Dotted line. And it is shaded below. And so we find the overlap. This section right here And let's pick 3 points in that region. So let's say 2, 0, 3, negative 3, and I don't know, let's go 5, actually let's go 6, 0, because that's on the red line, which is solid, so that's fine. Last one here. These are already in slope-intercept form, that's nice. So 1/2 x plus 4, we're going to go up 4, up 1 over 2, or down 1, left 2, and it gets a dotted line, and below, shaded below, less than. For the next one, 1/2 x plus 8, so this one starts at 8. It has the same slope, so again, this is a parallel line. We'll see what that means for the shading. This one is also a dotted line, and it gets shaded above. So we have to find where these two regions overlap. However, they do not. They do not overlap. So there is no solution here. So it is possible for these to have no solution, and that is if the shaded regions do not overlap, which in this case you can see for the red line we shaded below, for the blue line we shaded above. They will never cross, those regions will never overlap, so there are no points that make both of these inequalities true. That will never work out. Okay, so there it is. Graph both inequalities on the same coordinate plane, find where the shaded regions overlap, and that is where your solutions live.